Look here, neither E plus Q nor E minus Q are in E plus Q and E minus Q, neither in same direction nor in opposite direction. So neither in same direction nor in opposite direction. So it is in opposite direction. So this is in same direction. So that's why I can't use the theory of R is equals to P plus Q or R is equals to P minus Q. Okay. So they are acting at an angle of theta plus theta 2 theta. Therefore, so here a different technique is to be adopted to work out the resultant field E P bar. What is that technique? Let us resolve E plus Q and E minus Q into two mutually perpendicular components. Last year theory, I will just call it last year theory. Here is a vector E bar and it is resolved into two mutually perpendicular components, one along x-axis and another along y-axis. So suppose it makes an angle, x-axis component is called horizontal component and y-axis component is called vertical component or normal component. Okay. So this is the x-axis, this is the y-axis, a bar makes an angle theta. Then x-axis component is ax bar is equals to a cos theta I cap, and y-axis component, this much is the y-axis component, ay bar is equals to a sin theta j cap, is it not? So that is the resolution of a vector. So now this E plus Q, E minus Q are resolved into two mutually perpendicular components, horizontally and vertically. Vertically also called as normally. Actually, the normal components are equal and opposite, cancels each other. Equal and opposite and cancels each other. And vertical components are actually cancels each other. And horizontal components acts in the same direction, adds up to give the resultant field. Only horizontal components act in the same direction and they cancels each other to produce the, they adds up. Vertical components cancels each other and horizontal component adds up to give the resultant field EP bar. Okay. Therefore, E plus Q and E minus Q are resolved into two mutually perpendicular components. The normal components of both cancels each other. E plus Q and E minus Q bar are resolved into two mutually perpendicular components. The normal is vertical. Components of both cancels each other and horizontal components acts in the direction of minus p cap, acts in the direction of minus p cap, adds up, both adds up, both adds up to give resultant field at resultant field EP bar at the point P at P. Okay, I will show the diagram also. Okay, how the normal component cancels and vertical components, horizontal component adds up. Okay, so I will give the diagram. This diagram is not necessary for examination. So this is E minus Q bar. Okay, this is, you get the diagram, E plus Q bar, and actually this is also theta, this is also theta. This is the vertical component of E plus Q. This is the horizontal component of E plus Q. Horizontal component acts like this, acts like this horizontally, E plus Q cos theta. Horizontal component, vertical component is E plus Q sin theta. And this one is E minus Q. This is the resolution of E plus Q. E plus Q is resolved horizontally, E plus Q cos theta, and E minus E plus Q sin theta, vertical component. E plus Q here. E plus Q is resolved horizontally, its component is horizontal component E plus Q cos theta. It is resolved vertically, that is E plus Q sin theta. And E minus Q also resolved. E minus Q is acting in this direction now. It is E minus Q, it is E plus Q. E plus Q horizontal component is this one, E plus cos theta, vertically is E plus Q sin theta. Now E minus Q, its vertical component is E minus Q bar sin theta. E minus Q sin theta. Let's work out the magnitude only sin theta. And this horizontal component, the vertical component of E minus Q, horizontal component is it is E minus Q sin theta. Where E minus Q cos theta. E minus Q vertical component is E minus Q sin theta. Horizontal component is E minus Q sin theta. So look here, this E minus Q sin theta, E plus Q sin theta are equal and opposite. Why? The magnitude of E plus Q and E minus Q are equal at the point P. Because the distance is same now. PB is equals to PA and the magnitude of the charge is same, Q and Q. Therefore, the charge is same, distance is same. Therefore, the field at the point P due to E plus Q and E minus Q, the magnitude of the fields E plus Q and E minus Q are same at the point P. Therefore, E plus Q and E minus Q are equal. Okay, E plus Q is equals to E minus Q in this case. Let us work out both later on. Okay, and therefore E plus Q and E minus Q sin theta are equal and opposite. When two vectors are equal and opposite acting at a point cancels each other, then the resultant will be 0. But therefore there is no field along the vertical direction. Along the vertical direction, field is 0. Okay, along the vertical direction, the field is 0. On the equatorial plane, actually, on the equatorial plane, field is 0. So okay, in the horizontal direction, now both E plus Q cos theta, E minus Q cos theta acts in the same direction, adds up to give the what? The resultant. That is the diagram. So in the examination, we need to show this diagram here. E plus Q cos theta in the upward direction, E minus Q sin theta in the downward direction, because this is the E minus Q, no? E minus Q, this is the vector. Two mutually perpendicular components are horizontal, vertical. Unless the vector which is resolved comes in between the horizontal and vertical. The vertically downward for this one. Don't take like this. This is not the vertical component of this vector, because the vector should be the vector we are going to resolve it comes in between the horizontal and vertical. This is the horizontal, this is the vertical component of this vector. A bar is resolved. This vertical component is like this. Horizontal component is like this. Okay. The vector which is resolved comes in between its components vertical and horizontal. Therefore, its vertical is like this, horizontal is like this. E plus Q vertical component is like this, horizontal is like this. E plus Q comes in between vertical component and horizontal component. Okay. Therefore, now let us work out what is the E plus Q and what is the E minus Q. Let us work out both E plus Q. E plus Q is equals to E plus Q. Magnitude only let us work out. Or even bar also. Okay. E plus Q bar is equals to 1 upon 4 pi. So not charge is Q upon the distance. The distance is AP. Okay. The field at the point P due to the charge plus Q. E plus Q is the field at the point P due to the charge point charge plus Q. Then it is at a distance of P. For a single point charge, the field is 1 upon 4 pi epsilon charge upon square of the distance between the point and the charge. Therefore, it is modulus of Q divided by AP square into that. So let's work out the magnitude. Direction is not possible to give. Here, direction is not possible to give because it is neither in vertical direction nor in horizontal direction. Okay, E plus Q is neither horizontal one nor vertical one. Let's work out the magnitude. So it is equals to AP square by AP by Pythagoras theorem. So it is AP square is equals to, let us work out AP square here. AP square is equals to OB square plus OP square. OB square plus OP square. Therefore, it is equals to OB square is A square and it is R square plus A square. Okay. Similarly, BP square is also same, AP square, and BP square is also BP square is also equal to A square plus R square, or R square plus A square. Okay, and with the cos theta is equal to opposite upon hypotenuse. Opposite is adjacent upon hypotenuse. Cos theta is adjacent. Adjacent is OB, and hypotenuse is PB. Cos theta is OB upon OA upon AP. Adjacent upon hypotenuse. OA is A, and AP square is A square plus R square. Therefore, AP is the root of A square plus R square. Therefore, E plus Q is equal to 1 upon 4 pi epsilon naught Q upon R square plus A square. And similarly, E minus Q, only magnitude I am working out, 1 upon 4 pi epsilon naught Q upon modulus of minus Q upon R. It is BP square. This is BP square. But BP square is same as AP square. These two sides, AP and BP, are equal in length, because look at this is the midpoint, no? Axial line, equatorial line means this is the midpoint. Therefore, this distance and midpoint means OA equals to OB. So it is a perpendicular bisector. Actually, PO is the perpendicular bisector. Then perpendicular bisector, every point of the perpendicular bisector are at equidistance, okay, from the point A and B. Therefore, PA is equals to P. Therefore, it is equals to E minus Q is also equals to 1 upon 4 pi epsilon naught. It is the field to the single charge. This formula. So, even though we are working out the resultant, but are in the problem, we are working out the resultant of multiple charges, but you have to work out the field due to the single charges by the basic definition. Field at a point due to a point charge is 1 upon 4 pi epsilon naught. Magnitude of the charge divided by square of the distance R square between the charge and the point. So, individual field due to the individual charges is by the basic definition 1 upon 4 E bar is equals to 1 upon 4 pi epsilon naught Q upon R square into R cap. It is not 4 pi epsilon naught. It is Q upon BP square is also R square plus A square. Look here, the magnitude of E plus Q and E minus Q are same. E plus Q and E minus Q are same. Therefore, their vertical components sin E plus Q and E minus Q sin theta are equal and opposite. Cancels each other when two vectors of same magnitude acting in the opposite direction, then the resultant is 0. Okay. So, and both horizontal component both acts in the same direction. Therefore, both adds up to do the resultant field. Okay. Now, the resultant field. Coming to the resultant field. Okay. Resultant field. Resultant field. Coming to the resultant field. Final step. EP bar is equals to actually E plus Q bar cos theta plus E minus Q bar cos theta. Okay. E plus Q cos theta and E minus Q cos theta acts in the same direction. And they act in the direction of minus P cap. In which direction they act? E plus Q cos theta and E minus Q cos theta. Look at the diagram. They act in the, this is E plus Q cos theta and this is also E minus Q bar cos theta. Both acts in the same direction of P cap is in this direction and this is the minus P cap, opposite direction of P cap. Look at the diagram. Okay. Therefore, E plus Q magnitude is 1, therefore it is both are in the same magnitude 1 upon 4 pi epsilon naught. Cos theta is common, then it is Q divided by R square plus A square into cos theta is how much? Cos theta is, so it is E plus Q magnitude only I have written. I will give the direction. So it is cos theta is, it is A upon the root of A square plus R square. Okay. A upon root of A square plus R square. It is E plus Q magnitude cos theta. And bar is there, no? Bar means this component acts in which direction? This component acts in the opposite direction of p cap, therefore minus p cap. Bar in means you have to mention the direction. This component e plus q cos theta and e minus q cos theta acts in the opposite direction of p cap. Therefore, bar is taken means direction you have to mention. The direction is minus p cap plus 1 upon say 1 upon 4 pi epsilon q divided by r square plus a square into cos theta. Cos theta is a upon root of a square plus r square into minus p cap. Therefore, same quantity is added twice. E plus q and e minus q cos theta are having the same magnitude. E plus q and e minus q are having the same magnitude. Cos theta is same a upon root of, and both acts in the minus p cap direction. That's why both it is p cap and this direction is minus p cap. E plus q cos theta, e minus q cos theta acts in the, we can put it as one bar. Okay. And this here also you can put bar. That's why now it is 1 upon 4 pi epsilon naught, which is common. Everything is common. It is 2 times of. The same quantity is added twice. Therefore, it is 2 times of 1 upon 4 pi epsilon naught. So a little bit of complicated derivation. So here the e plus q bar and e minus q bar are not acting in the same direction. So not acting in the either in same direction or in opposite direction. They act at an angle of 2 theta. Therefore, a different technique is adopted here. Now, r is equals to root of p square plus q square plus 2pq cos theta. That concept is also not used here. So that what concept is used? The e plus q and e minus q are resolved into horizontal components and vertical components. Vertical component cancels each other, and because they are equal in magnitude and opposite direction cancels each other, and the horizontal component acts in the same direction. The horizontal component adds up to give the resultant field at the point P. Okay, resultant field at the point P. One upon 4 pi epsilon naught into q upon what it is r square qa upon r square plus a square raised to 3 by 2. Why it is 3 by 2? It is same quantity, no? R square plus a square is also r square plus a square. A square plus r square is same as r square plus a square. A raised to 1 into a raised to half is square root is raised to half. X raised to 1, x raised to half is x raised to 1 plus half. That's plus x raised to 3. Same quantity. R square plus a square, the r square plus a square raised to half. Therefore, it is, so let us maintain 1 upon 4 pi epsilon naught in the formula, because 1 upon 4 pi epsilon naught value is 9 into 10 raised to 9. Therefore, 2 ones are 2 2s are cancels, x plus x is 2x. Why you got what it is 2 times? Because same quantity adds up twice. Therefore, it is 2x minus p cap into minus p cap. Direction is necessary. When you are putting the bar for the vector, you have to mention the direction. X plus x is x, this is x plus x is 2x, and y it is raised to 3 by 2, a raised to 1 into a raised to half. This quantity f of x raised to 1 into f of x raised to half is f of x raised to 1 plus half, f of x raised to 3 by 2. Okay, it is raised, square root means raised to half, no? Square root is nothing but root of x, nothing but x raised to half. Therefore, I won't cancel 2 ones are 2 2s are, because 1 upon 4 pi epsilon naught itself is 9 into 10 raised to 9. That's why let us maintain 4 pi epsilon naught as it is. Therefore, it is 2 qa upon 4 pi epsilon naught EP bar resultant field 4 pi epsilon naught into 1 upon, better to write 1 upon 4 pi epsilon naught into, here comes 1 minus. Let us maintain minus p cap here. Okay, it is 1 upon 4 pi epsilon naught 2 qa upon r2a cube upon r square plus a square whole raised to 3 by 2 into minus p cap. Okay, minus p cap. You can take 1 minus in the beginning also. Let us see what is in the textbook. Okay. Final presentation final value is 2qa 4 pi epsilon into r square plus a square raised to 3 by 2 into p cap. So here we have to take the minus. That minus p cap is written here. Okay, we know that 2aq is nothing but p. 2aq is nothing but the magnitude of the dipole moment. I can write it as p. 2aq, p is equal to 2aq. When the minus is there, let's put it up. This bracket 2aq. Minus is already taken out now. Put it up bracket. So p is equal to 2aq. 2 is the dipole moment, magnitude of the dipole moment. Therefore, EP bar is equal to minus 1 upon 4 pi epsilon naught p upon r square plus a square raised to 3 by 2. Okay, raised to 3. These things written in the bracket are not necessary. Round up. Things are rounded up now. You need to write it in examination. Okay. Therefore, EP bar is equal to, this is the end of the derivation. Here also we can end the derivation into p cap. Elegant one, not elegant one. So P, the dipole moment, P is equal to 2aq. For a short dipole, note elegant one is elegant. Note for a short dipole. For a short dipole, A is far smaller than R, the distance between the origin and the point, midpoint O and the point P is far greater as compared to the semi-axis of the dipole. Axis is 2a, semi means half axis is a. Semi means half of the total length. 2a is the total length of the axis, semi means half of that axis is 2a upon 2, that's a. If a is far smaller as compared to the R, what is the R here? The dipole R indicates distance between the midpoint of the dipole and the point P. What is the point P? The point P is one where you would like to assess the field at that point in the space. Therefore, R square plus A square is nearly equals to R square. This is negligible. 100 square plus 1 square. 1 is negligible. Or 0.1 square is negligible. Therefore, 100 square plus 0.1 square is almost equals to 100 square. Therefore, EP is equals to, this minus sign indicates the direction of the resultant field is in the opposite direction of P cap. P cap is in the directed form minus Q2 plus Q. Therefore, minus P cap in the resultant field acts in the direction of not minus Q2 plus Q, in the opposite direction of P cap. The P cap, the dipole moment, unit vector, dipole moment, P cap is the unit vector of the dipole moment, P bar. Then P bar acts in the direction of minus Q2 plus Q, but no. Minus P cap means it is acting in the direction of plus Q2 minus Q. Therefore, the resultant field on the equatorial plane acts in the direction of plus Q2 minus Q, not in the direction of minus Q2 plus Q. Okay. Therefore, it is minus 1 upon 4 pi epsilon naught. LNB derivation, how to practice it. Okay. Not understood? Anyhow, if you are not understood, revise the video. Every point is explained. Okay. So normal components are equal in magnitude and cancels each other. Equal in magnitude and opposite in direction cancels each other. Both cancels resulting to mutually perpendicular components. The normal components of both cancels each other. Why cancels each other? Because they are equal in magnitude and opposite in direction. Horizontal component acts in the direction of minus P cap. Therefore, both adds up to give the resultant field EP bar at P. Both adds with normal components, horizontal components adds up to give the resultant field EP bar at P. Horizontal component is cos theta, vertical component is sin theta. Is it not? E plus Q bar sin theta is the vertical normal component. They are acting in the opposite directions and equal in magnitude. Why? E plus Q is equal to E minus Q. Therefore, EP bar is equal to, it is minus 1 upon 4 pi epsilon naught. It is 2aq upon, look here, r square plus a square is r square, no? R square raised to 3 by 2. R square raised to 3 by 2 cancels upon r cube into p cap, or EP bar in terms of dipole moment. EP bar is equal to minus 1 upon 4 pi epsilon naught 2aq is P upon RQ into PQ. They are not. So that is the end of the derivation. Okay. So let us solve some problems on this dipole. I will give you a problem and you have to, but it is, solve it. You have to solve it, simple substitution. Usually a problem on dipole, if it is there, it is on a short dipole only. Okay. The question is two charges, the question problems, two charges. If you have not understood any point in this particular derivation, just ask me. So I have not understood which particular point, because in textbook it is given very briefly. Okay, you can't understand text, but it is derivation given in the textbook. Two charges problem, two charges plus or minus 10 microcoulomb. Microcoulomb is 10 to the power of minus 6. One is plus q and another one is minus q. Are placed 5 millimeter apart. Are placed 5 millimeter. Milli means 10 to the power of minus 3. 5 millimeter is equal to 5 into 10 to the power of minus 3 meter, because SI unit ought to be used. No, SI unit of distance in meter. Therefore, 5 millimeter is equal to 5 into 10 to the power of minus 3 meters. To convert it into meters, with the suffix milli is equal to 10 to the power of minus 3 apart. Determine the electric field. It is a dipole, no? It is a dipole plus or minus 10 microcoulomb, two charges plus q and minus q. Q is equal to 10 microcoulomb and what it is 2a is equal to 5 millimeter. Or placed 5 millimeter apart, means distance between plus q and minus q is 5 millimeter. Okay. Determine the field at first one 50 meter away from the center O. 50 centimeter. Look here. A is 2.5 millimeter. R is 15 centimeter. 15 centimeter is far bigger than, but it is 2.5 millimeter. Therefore, a short dipole formula should be taken. Short dipole formula, not okay. 15 centimeter from the midpoint. O. Midpoint O of the dipole. Midpoint O of the dipole in the side of plus q. In the side of plus q, positive charge, means plus q is plus 10 microcoulomb and minus q is minus 10 microcoulomb on the axial line. On the axial line means which formula is to be taken? Field at a point on the axial line, first derivation. Okay, that's the short dipole formula. Second one, on the equatorial line. On the equatorial line, at a distance of 15 centimeter. Both are 15 centimeter. Okay. On the equatorial plane, at a distance of 15 centimeter. Centimeter means 10 to the power of minus 2. Everything is to be converted to meter, millimeter, centimeter. Centimeter is 10 to the power of minus 2. 15 to 10 to the power of minus 2 meters. 15 centimeter from O. Therefore, in both the cases, R in the distance between what it is, the center O and the point P. Therefore, R in both the cases is 15 centimeter. Use the short dipole. Here A is equals to 2.5. 2A is equals to 5 millimeter. Therefore, A is equals to 2.5 millimeter. R is equals to 15 centimeter. 2.5 millimeter is far smaller. Therefore, A is far smaller as compared to R. Use short dipole formula. Short dipole. Just substitution in the formula. That's all. Use short dipole formula. You have to calculate short dipole. formula.